What's up, math scholars and math haters? This is Mr. W. Today we're going to tackle question 36 in the 7th grade math questions that North Carolina released this past school year. The question gives us a graph that shows the time and distance traveled for two objects, and we are supposed to figure out which of these statements is true. Now, this question is going to deal with the idea of slope. The idea of slope is just that we figure out how much for any line, any of these two objects, how much this variable is changing, so how far we're traveling, and divide that by how much this variable is changing, so how much time we're taking. So finding slope is going to be part of it, and we're also going to have to do some subtracting fractions with different denominators. So let's go ahead and get started. So I'm going to look at my answer choices, and I'm going to see that the way these are written is actually going to be very helpful to me, because I see foot per minute, foot per minute, foot per minute, foot per minute. And what that tells me is that for each of these objects, Object 1 and Object 2, I'm going to try to find some number of feet that they're traveling and divide it by some number of minutes. So if I start with Object 1, the easiest place to start is where the x-axis and the y-axis meet, and then I'll find another dot that goes right on top of the grid line, so that's here. And so if I'm trying to think about how many feet I'm traveling, this line is right between 10 and 20, so I'll call that 15. So this is now 15 feet and as I go down, I see that it matches with 10 minutes. So Object 1 is traveling 15 feet in 10 minutes. I move on to Object 2, and once again, it's going to be easiest for me to pick this as one of my points. Next easiest point to deal with is going to be right here. And then I'm still going to try to find feet and minutes for Object 2. So Object 2 is actually just traveling 10 feet in 15 minutes. So as I go down now, I meet this line that's right between 10 and 20, so I'm calling it 15. So Object 1 is traveling 15 feet in 10 minutes. Object 2 is traveling 10 feet in 15 minutes. I'm going to go ahead and simplify these to make the numbers easier to work with. So let's see, 15 divided by 5 and 10 divided by 5 is going to give me 3 over 2. So now we can think of this as 3 feet in 2 minutes. And if we keep that pattern going and keep that proportionality aspect of it, that's going to give us 15 feet in 10 minutes if it repeats this cycle 5 times. And similar for Object 2, divide by 5 and divide by 5. Object 2 is traveling 2 feet in 3 minutes, and if we keep that going 5 times, we'll get to 10 feet in 15 minutes. So either way, we have 3 halves and 2 thirds, and our goal is now to see which one is traveling more and by how much. So if I come back to these fractions and I look at these, I see 3 halves and I think, okay, that's a whole, that's 1 plus a half. I see 2 thirds and I think that's definitely less than 1. So between the more than 1 and the less than 1, I'm saying that Object 1 is traveling faster, which means that A and B are both out as answer choices, because they both would only be true if Object 2 were traveling faster, which it's not. So now we just have to figure out exactly how much faster Object 1 is traveling, and in order to do that, we're going to need to do some subtraction. So now I'm trying to figure out what is 3 halves minus 2 thirds. And I know that adding and subtracting fractions of different denominators can be tricky if your smaller denominator does not go evenly into your big denominator. So this is where I actually want to bring out my big board and show a trick that one of my colleagues taught me that I think is very useful and relatively simple. So with the magic of editing, my big board is going to appear right about now. So if I'm trying to figure out what 3 halves minus 2 thirds is, I'm going to think about my numerator and denominator separately, and I'm going to use a separate trick for each one. For my denominator, I'm going to just multiply the other two denominators. So 2 times 3 gives me 6. And now for my numerator, I'm actually going to cross multiply. And I'm going to say that This is 3 times 3, which is 9. I was subtracting the fraction, so I need to subtract 2 times 2, which is 4. So 3 times 3 gives me 9, 2 times 2 gives me 4. That's where my cross multiplying comes in, although it's a bit different from if I were using this trick to solve a proportion. But either way, I end up with 9 minus 4, whatever that is, over 6, and that equals 5/6. So this is how much faster object 1 is traveling than object 2. And I need to go back to my answer choices and find the one that says object 1 is traveling 5/6 of a foot more per minute than object 2. So there we go. The trick with this question was thinking about the slope of each of these lines as a fraction, and then going from slope language to fraction language to do the math and find this difference.